Hey everyone, welcome back to my YouTube channel Code with Deepa. So today is day 54 of solving daily problems on Geeks for Geeks. Now let us see what today's problem is. So the problem is to construct a binary tree from its in-order and post-order traversal, and this problem is asked in Amazon, Microsoft, Hike and Adobe. So we will solve this problem, and this problem contains tree data structures and recursion. Okay, so we will also use recursion to solve this problem. So now let us first read this problem. So the problem says that construct a binary tree from the in-order and post-order traversal of the tree given in arrays. Okay, so in here refers to the in-order traversal and post here refers to the post-order traversal. Our task is to use these traversal and construct a new binary tree. So let us first see what is in-order, pre-order and post-order traversal. These are the techniques used to traverse a tree, and they uh, they follow different ways. Like in order traversal, what we do, we start from the left subtree, then we take the root element, and then we take the right subtree. Okay, so this is for in order. And how we traverse in pre-order, we first take the root, then we go to the left child, and then we process the right child. And it is different from other two traversal post order. Okay, in post order, what you do, you traverse the left subtree, then you move to the right subtree, and then you move to the root. So in this question we are given with the in order and post order traversal. So let's say this is my given binary tree. So for this tree, if I try to calculate the in order traversal, then it would be like this. Okay, so I will start from the left subtree. See, for this root node, my left subtree will be here. Then I will again move to the left subtree. Okay, then the first node will become 25. Okay, now next node will be, after left you have to move to the root. Root is 30. Next node here will be the right child, which is 35. And then again I will move to the root node. My left is completed, then I will write the root node. Okay, and after that I will process the right. Now in right also I will first take the left child, then I will move to the root, and then the right child. Okay, so in the left side we have 45 first, then we have 50, and at last we have 60. Okay, so there is one more property related to in order traversal, that you get your tree in a sorted order when you do in order traversal. Okay, if we do the post order traversal for this given tree, so for post order traversal we have to move from left, then we'll move to the right, and then we'll move to the root node. Okay, so first here we will move to the left subtree. We reached here, the first node here will be 25 in the left. Okay, so now let us write the post order traversal for this given problem. So post order will be like, first we will reach 25, then we will traverse the right node for this, then we'll move to the root node. Okay, and after that what we will do, we will again move to the right subtree, and here I will check for the left node, then the right node, then the root node, and at last what will have our root of the tree. So as you can see that in order traversal we get the root of binary tree in between somewhere, and in post order traversal we get the root of binary tree at the end of our traversal or at the end of our array. Same goes for the pre-order traversal. In pre-order traversal you get your root node of the array or tree in the first. Okay, if we do the pre-order traversal here, what we will get, that we have to first take the root node. We will take the root node, then we will move to the right hand side, left hand side, and we'll take the root node. Then we have to move to the left subtree, then we will move to the right subtree, and in right part also what you will do, you will first take 50, which is the root node, then you will traverse the left subtree, and at last you will traverse the right node. Okay, so this will become the pre-order, and here you can see that the root node is at the front of my array. So now we have to use these two traversals in order to calculate our tree back. Okay, so what we do, we will use a recursion. We will make recursive calls for the left subtree and the right subtree. First, I will find the index of my root node in my inorder traversal with using the pre-order array. Okay, so which is using the post order array. Here we will find the index of our root node, and then we will create a new node. Okay, with this particular value I will create a new node, and for this new node I will make a call to its left subtree and right subtree recursively, and that's how we will calculate the tree from this given two arrays, which is in and post order. Okay, so now let us see the code in order to try to understand it more properly. Let's see the code. Okay, so the first here is our base case, that if there is no root exists, then in that case you just return a null PTR, that there is no possible tree for this null. Okay, null value. Now the next is to find the root index in my inorder traversal with the help of post order. Okay, so this is my root index, that where my root value is present. Initially it is 0. Now it should be less than n. N is number of nodes present in my tree, or you can say the size of my array, and it should not be equals to the end of my post array. So until then we will increment our root index to get that index value where my root is present. After that we will create a new node with the help of this post order function, and here we are passing n, which is number of nodes. After that we'll make a call for recursive call for the left subtree and the right subtree. So now let us see what we are passing as parameters in the recursive calls. So for buildTree we are just passing the in and post array and our root index, which we have calculated here. Okay, every time this index value will change, and we will either traverse in the left part of my array, or I will traverse in the right part of my array. So in the right subtree what we are doing, for the left we are just passing the arrays, but for the right side we have to pass the sub array, which is on the right hand side after the root node. Let's say we are, see, for the left we are passing this much of array and whole array, but for the right hand side I need only this much part. So for that what we will do, I will pass this sub array, and how I will calculate the index of the sub array is like this. I will take the in where it is present, I will add the root index to it plus 1. So let's say for the first value I am here at 40, and I will pass from 45 to my next array. Okay, same goes for the post, that I will add the root index to it, and here my n value will be n minus root index value. So if number of nodes are 1 2 3 4, 7 nodes are there, and my root is present at 1 2 3 4, at 4. Okay, so I will just subtract 4 from it, I will get 3, and that will be my new node value minus 1, which will become 2. Okay, and then just you have to connect these. You will connect this by root left will be equals to the left subtree, this is the node value you are getting here, and node right will be equals to the right subtree whose value is here, and at last just return the root, which is the which is our answer. Okay, so now let us try to code this problem. Here first we have to check for the base case, that root is equals to null ptr, then in that case return null pointer. Okay, so this is our base case to check that if there is no such point exist or in my array. So instead of root we will use n, because n is the size of my array. If it is equals to 0, then in that case you have to return a null pointer. Now I will create here another variable to find my root index. Let's say initially it is 0. Now let's calculate our root index. It should be less than 0, and my root index in my Inorder array should not be equals to my post order array n minus 1. Okay. If it is not equal, these two conditions are true, then in that case you simply increment for your root index and your root index value is created. Now next is to create a new node, which we will name as root node. We'll create this root node, which will be new node, and here I will pass the value from my post array, which will be post n minus 1. Okay, initially this will create my first root node here, and after that what we will do, we will make a recursive call for my left and right subtree. Okay, to make a recursive call for my left subtree, what we will do, left sub. Now here we will again call this function buildTree, and here I will pass the in array, post array plus my n minus 1 value as my left subtree. Oh sorry, here we will pass directly the root index. Okay, now it is done. Let us just copy this and paste it down for the right subtree. Now for the right subtree, what we will do, we'll first pass the subarray for our in, and to calculate the subarray, what we will do, we will add the root index to it, plus 1 will become my right. Okay, I will pass the right array, and then in post what we have to do, we'll just add our root index to it, and that part of array will be passed to the recursive call. Okay, and the index here will be calculated as okay n minus root index minus 1. This will be for my right sub part. Okay, the last step here is to connect these two. So my root left will become equals to left sub. Similarly, my root right will become equals to right sub, and at last we will return our root node. Okay, so now let us try to run this code. It's taking time. Let us compile this again. Oh, it is producing wrong output. Okay, 137625548. Let us check what we are missing here. We are connecting the left and right subtree, and it is n plus root index plus 1, post plus root index, and subtracting. Okay, this part is correct, and for the left subtree also we are calculating correct. We are creating new node. Base case we have written here. Root index is okay. This condition should be root index not less than 0, should be less than n. Okay, which is the size of my array. Now it is accepted, and let's just submit this to test for other test cases also. Okay, so we have solved today's problem of the day, and I hope this video solution was clear to you. If you have any doubt, please leave it in the comment section. Like this video, comment on it, subscribe to my channel to get daily notification about the videos I'm posting here. Thanks for watching. I will see you in the next video.